Solar is absolutely essential for the energy transition, but today, less than 3% of energy generation is from solar panels. If we want to achieve these net zero targets, we need to bring solar up to 50%. So the combination of perovskite with silicon in this form of a tandem solar cell will generate the lowest cost of electricity, period. We're a spin-out from the University of Oxford, and we're focused on developing materials called perovskite for solar cell applications, and hopefully we can accelerate the adoption of solar, which of course is essential to decarbonize the world and address the climate crisis.
It is a very exciting time to be involved in material science and technology. There are some huge technical challenges to be achieved throughout the transition to net zero. So lots of companies work very closely with academia to deliver the technologies that they need to implement in their new products.
So the R&D center is where the actual solar cells are first prototyped and developed. So from concept, so the composition, the materials, to building a small device, and then the processes and cells that are developed here are then transferred to our production facility or a pilot line first in Germany. 95% of the solar today uses these kinds of square-shaped pieces of silicon, and what we do is we put some of this perovskite material on top of that silicon solar cell. We call it silicon on steroids. Of course, what it really means is kind of like turbocharged silicon. It takes that same silicon wafer, we add this perovskite material on top of it, and now that solar cell is about 20% more efficient than the silicon solar cell that it started with.
That's just an astonishing rate of increase of power. That's what's exciting the solar industry, because of its potential to make cheaper solar power and therefore answer the problems with climate change. What's cute about it is that you can print these things at room temperature. And so you won't have the high energy budget it costs to make crystalline silicon. It's easy to print the kind of perovskites you need for solar cells in the lab.
So one of the things that we've done carefully is to make sure that the materials we source, the chemicals themselves, the raw materials, we make sure it comes from what we call responsibly sourced areas. That means not made with any forced labor. It means sourced from areas where there is no conflict. It also means primary mined, so they're not a result of mining another material. And we also make sure that there's enough in the world to provide as much as 30 terawatts of PV. That's enough energy for production PV to power the planet for the rest of the century. Imagine being in a company that potentially can change the world or move the needle on, the energy transition. That's about as exciting as it gets.